Predictive analysis is a very important topic in artificial intelligence. In this tutorial, we will learn about ensemble learning, decision trees, creating decision trees in Python. Now, what is ensemble learning? Ensemble learning refers to the process of building multiple models and then combining them in a way that can produce better results than individual models. So basically, we are combining models in ensemble learning. These individual models can be classifiers, regressors, or anything else that models data in some way. Now let's take a real life example. Suppose you want to buy a new TV, but you don't know what the latest models are. Your goal is to get the best value for your money, but you don't have enough knowledge on this topic. So now what will you do? When you have to make a decision about something like this, you go around and try to get the opinion of multiple experts in the domain. This will help you make the best decision. Instead of just relying on a single opinion, you tend to make a final decision by combining the individual decisions of those experts. Now, what are decision trees? A decision tree is a structure that allows us to split the data set into branches and then make simple decisions at each level. This will allow us to arrive at the final decision by walking down the tree, and that's why its name is decision tree. Any decision process starts at the root node at the top of the tree. Each node in the tree is basically a decision rule. Now, what is concept behind decision tree? Decision trees are based on the concept of entropy, that is, measure of uncertainty. One of the main goals of a decision tree is to reduce uncertainty as we move from the root node towards the leaf nodes. When we see an unknown data point, we are completely uncertain about the output. By the time we reach the leaf node, we are certain about the output. So, in this way, uncertainty is reducing. This means that we need to construct the decision tree in such a way that will reduce the uncertainty at each level. Building a decision tree classifier. Let's see how to build a classifier using decision trees in Python. Let's see the program. Here we have imported few packages. These are your NumPy package. This is matplotlib package for plotting purpose and sklearn. Sklearn is very important package here. Sklearn is representing your scikit-learn package, and we will use this package for creating our decision tree. Next, utilities. Utilities is not a package, it's a class, and we have created that class and we have defined visualize classifier function in that class. So we are importing this function. Okay, first step is to load input data. So we have defined our data in this file, data decision trees.txt file. So we are loading data from that file. So for that we are using load.txt function of NumPy package. This file is containing data in comma separated value format. So we are using delimiter equal to comma for that. Next we are applying slicing operation on data variable. So we are getting our data in x and y variable. Now this y variable is either containing 0 or 1. So for that we are using it as a label for getting data from x variable. So we have separated our data into two classes based on labels. So this is your class 0 and this is your class 1. Next we are visualizing our input data. So for that we are using scatter function. Scatter function is defined in your pyplot package of matplotlib package. So this function is used to visualize, or you can say you have to create plot for that. So we are passing few parameters in this. Marker is very important parameter here. Marker equal to x is representing your class 0 data and marker equal to o is representing your class 1 data. Here title is your input data for that plot. Next we are splitting our data into training and testing data sets. For that we are using cross validation package and train test split function. We are passing test size as parameter. So test size is your size of testing sample. 0.25 is representing your proportion of the size. Random state is representing your random data generator. X and Y are your input data. Next, decision trees classifier. So we are creating decision trees here. So we are using decision tree classifier for that. Decision tree classifier is a class capable of performing multi-class classification on a dataset. So we are classifying our dataset into multiple classes, or we can say we are creating decision trees from that dataset. We are passing parameters here. These are your random state for random data generator and max depth. It is representing your height of the tree, which is 4 here. Okay, next we are using visualize classifier function, which is defined in your utilities class. So let's see this. Here we have passed classifier, your X train and Y train as data, and your training data set. So what are these? Let's see this. This is your visualize classifier function. We have passed classifier, X and Y as data, and title. Okay. First step is to define the minimum and maximum values for X and Y that will be used in the mesh grid. So we are defining here minimum and maximum values for X and Y using min and max function. Next, we are defining the step size to use in plotting the mesh grid, which we have taken 0.01. Next, define the mesh grid of X and Y values. So we are using mesh grid function for that. Next, run the classifier on the mesh grid. So we have done that using predict function of classifier. Next, reshaping the output array using reshape function. Then create a plot using figure function of pyplot package. And then we are specifying the title, that is plt.title. So title is a function of pyplot package. Next, we are choosing a color scheme for the plot. So for that we are using pColorMesh function. Then we are using again scatter function for overlaying our training points on the plot. Then we are specifying the boundaries of the plot. So for that we are using xlimit and ylimit function. Then we are specifying the labels. Text means labels on the x and y axis. So for that we are using xtext and ytext function of pyplot package. So here matplotlib package is very important to import. We are importing here numpy and matplotlib package because it is this method is for plotting. Okay, let's back to the program. Here we have used visualize classifier function for visualizing our training and testing data sets. After that we are evaluating our classifier performance. So for that there is an inbuilt function classification report. So we are using that function. We are passing parameters, 4 parameters here, and similarly we are creating classification report for testing dataset, and here is classification report for training dataset, and then we are using show function. Okay, now run that program. Let's see the output. It is running now. Okay, this is your plot for input data. Remember we have used marker equal to x and o for class 0 and 1. So here are marker. This is o and this is cross. So this is representing your class 0 and this is representing your class 1. So we have plotted our data. Then this is your training dataset and this is your test dataset. So this is your decision tree classifier where we have plotted our decision trees. So this is your training and this is your testing dataset. Then we are showing this classifier performance. This is your classification report. So we have 4 columns: precision, recall, F1 score, and support. So for that we have used our classification report function. This is for training dataset and this is for testing dataset. Okay, so this is your output for creating decision trees. You can create decision trees for any dataset, but it should be in comma separated value format.